If you want to have an active classroom, your students need to do some preparation before class. For me, that really means reading a textbook. The right textbook just wasn't out there. There wasn't a book that was based on physics education research. I wanted to have this active learning environment in my classroom, and I needed a book to support that. Students will do a lot of work if they're motivated to do that work, but they're often not motivated in a physics classroom. And I think the reason is traditionally the way physics is taught, there's no connection between physics and the human experience. Students just don't see that physics is relevant in their lives. To counter that, I wrote case studies. Case studies make exactly that connection. Each case study applies physics concepts to some human experience. Now that might be something that's happened in the news. For example, in Chapter 5, I wrote a case study based on a real train collision that took place in Los Angeles. Sometimes I use the case studies to talk about the historical discoveries made in science. So the case study in Chapter 24 is about a debate between Benjamin Franklin and his rival Benjamin Wilson. They both invented a lightning rod. Benjamin Franklin wanted his to be pointy. Benjamin Wilson wanted a rounded end. And I use that to talk about the importance of electric fields and how different shaped conductors will have different electric fields. Each chapter has at least one case study, and it's truly woven into the chapter. Near the beginning, the case study is presented as sort of a puzzle, something you're going to want to find the answer to. And then after the student learns a little more physics, there might be an example where we can answer part of the case study, or perhaps a conceptual exercise. Every chapter has at least one problem based on that chapter's case study, and online there are integrated tutorials for every case study.